For 85 years, to the human eye, it was nothing more than a few blurry pixels lost in the dark. But when the fastest spacecraft in history finally swept past it, we didn't find a dead, frozen rock. We found a living world with a heart made of ice, volcanoes that erupt water, and a thin, haunting atmosphere. Tonight, come with me to the farthest place humanity has ever touched. And right now, as you prepare to leave Earth behind with me, check your clock and look out your window. Where are you on this planet? And what time is it? Leave your location and timestamp in the comments below so we know who is traveling with us into the void tonight. The year 2015 brought a wave of extraordinary anticipation throughout the global space community, and for a very specific reason. Until that point, humanity's sharpest portrait of the Pluto system was a distant, indistinct collection of pixels. Even the powerful Hubble Space Telescope, when it turned its gaze toward Pluto, could only resolve a tiny, faraway world, revealing little more than a few blurry patches of varying color. But everything was about to change. After an immense journey spanning 9 years across the solar system, the New Horizons space probe was finally set to arrive, promising a level of detail and clarity of the dwarf planet and its moons that had never before been possible. The central questions were compelling. What marvels would New Horizons witness during its fleeting passage? And what would its mission become after leaving Pluto behind? To understand the significance of this encounter, it helps to place Pluto in its cosmic context. It is a surprisingly small world, considerably smaller than Earth's own moon. And it resides within the Kuiper Belt, a vast, diffuse ring of icy bodies orbiting beyond Neptune. As the last of the 9 celestial bodies traditionally considered planets to remain unvisited, its exploration was long overdue. This delay was partly due to its incredible distance from us, but also stemmed from a belief, now hard to imagine, that Pluto simply wasn't a particularly compelling target for a mission. Fortunately, the dedicated team behind the New Horizons concept advocated passionately for its approval. Their persistence paid off, and in 2006, the probe was launched as a component of NASA's New Frontier program, which supports medium-cost space exploration ventures. The primary objective was to reach Pluto in the shortest time feasible. To achieve this, New Horizons became the fastest object ever launched from Earth. The design paired a lightweight spacecraft with the most powerful rocket available then, a fully boosted Atlas V. This combination allowed it to speed past the Moon in a mere 9 hours, a journey that took the Apollo missions 10 times as long. On its long trajectory outward, the probe made a crucial flyby of Jupiter, using the giant planet's gravity as a slingshot. This maneuver successfully trimmed 3 years from its total travel time to Pluto. The Jupiter encounter also served as an invaluable dress rehearsal for its scientific instruments, yielding some truly remarkable images and videos of the gas giant and its moons. With this trial run successfully completed, New Horizons was placed into a state of electronic hibernation. This measure was taken to preserve its delicate systems and protect them from the wear and tear of a long voyage. As the 2015 approach neared, mission controllers brought the probe's systems back to life. In the final weeks, the spacecraft began sending back daily images of the Pluto system, each one better than the last. For enthusiasts following the mission's progress, it was a period of incredible excitement. We started to receive the first real hints of what Pluto's surface might hold, and we could clearly see how different the dwarf planet was from its largest moon, Charon. With every passing day, the resolution sharpened, allowing more and more surface details to emerge. While the mission had numerous scientific goals, for many, the most captivating aspect was simply seeing what this distant world actually looked like. Soon, an unmistakable feature came into view, a large, bright shape on the surface that strongly resembled a heart. On the 14th of July, the New Horizons probe executed its closest approach, passing just 12,500 kilometers above Pluto's surface. However, the mission team on Earth did not get to see the results immediately. The probe was far too occupied gathering a vast trove of data during the flyby to transmit anything back in real time. Once the data transfer began, it was a slow and patient process, hampered by an uplink speed of only 1 kilobit per second. Compounding this was the immense distance, which created a 4.5-hour communication delay between the spacecraft and Earth. But the images and information that eventually arrived were nothing short of spectacular. They revealed a world of towering mountain ranges, vast ice plains, flowing glaciers, and even a tenuous atmosphere. The probe also captured detailed views of some of Pluto's moons. One of the first remarkable discoveries concerned Pluto's strange relationship with its moons. Its largest companion, Charon, orbits very near to Pluto and is exceptionally large in comparison. This has an interesting consequence. The barycenter, or the shared center of mass between the two bodies, is located in the empty space outside of Pluto. In essence, they orbit a common point in space together, like partners in a celestial dance. What's more, both objects are tidally locked to one another. This means that from any point on Pluto's surface, Charon remains fixed in the sky, and the same is true from Charon's perspective. This mutual tidal lock is highly unusual. While many moons are tidally locked to their planets, it is rare for the planet to be locked to its moon in return. Visually, Charon is also quite distinct from Pluto, appearing much darker, which suggests they may not have formed from the same material. Pluto's other moons are tiny, measuring only a few kilometers across, and their orbits are noteworthy for being exceptionally circular and perfectly aligned with Pluto's own orbital plane. The geology of Pluto itself proved to be fascinating. The most prominent feature, the giant heart shape that captivated the world, has since been officially named Sputnik Planitia. This enormous basin, roughly the size of Texas, stands in stark color contrast to the darker, cratered terrain surrounding it. The reason for this brightness is that it is a colossal plain of frozen ice. The flyby confirmed that 98% of Pluto's surface is covered in nitrogen ice. At the average surface temperature of -229 degrees Celsius, water ice becomes as hard and brittle as rock. Nitrogen ice, however, behaves very differently at these frigid temperatures, acting much like water ice does on Earth. This means it can flow, forming glaciers. This glacial movement is especially evident along the edges of the heart-shaped region, where icy flows can be seen spilling into the gaps between craters and mountains. The surface of the ice plains is marked by a pattern of giant polygonal shapes across its entire area. A significant detail is the complete absence of impact craters, which indicates that this is either a very young feature, geologically speaking, or one that is constantly being renewed. Its age is estimated to be perhaps only 10 million years old. The polygonal cells have ridges along their borders, which are likely formed by sublimation, the process where ice turns directly into a gas. Here, ices regularly sublimate and refreeze, creating troughs and pits, which suggests these polygons are actually convection cells. These cells are in motion, slowly churning and pouring into the surrounding mountain ranges through the movement of glaciers. In many ways, Sputnik Planitia can be compared to Greenland and Antarctica, as it heavily influences and controls Pluto's global climate. While not yet confirmed, one leading theory suggests Sputnik Planitia may have formed from a massive impact, with the resulting crater being filled by ices from a potential subsurface liquid ocean. This massive, ice-filled basin actually creates a positive gravitational anomaly, a location where gravity is slightly stronger than on the rest of the dwarf planet. The ice plane is positioned directly opposite Charon, aligning it perfectly with the tidal axis between the two bodies. Because Pluto and Charon are so close, the tidal forces they exert on each other are incredibly strong. This powerful gravitational interaction is likely the very reason Pluto is tidally locked to Charon, forever ensuring these two distant worlds face one another across the void. Enormous mountain ranges composed of water ice frame the expansive ice plains, creating a spectacular silhouette when seen from the side. At Pluto's frigid temperatures, water ice is the only known substance with enough structural integrity to form mountains that rise for several kilometers. Among these towering peaks, there may also be cryovolcanoes. One of the most compelling candidates is a feature named Right Mons. It stands 4 kilometers tall, ranking among the highest points on Pluto, and is distinguished by a large depression at its center. The activity of such cryovolcanoes could be a key factor in explaining Pluto's remarkably young surface. An exceptionally interesting region is an area called Tartarus Dorsa. This is a vast and very distinct collection of 500-meter-high mountains that have a texture resembling snakeskin or the bark of a tree. These formations are believed to be penitentes. If this hypothesis is correct, Pluto would be the only body in the solar system besides Earth where they have been found. Even on our own planet, they are quite rare, appearing only in dry, high-altitude places like the Atacama Desert. The structures on Pluto, however, are significantly taller and cover a much more extensive area than their terrestrial counterparts. One can only speculate what they might look like from up close. Another prominent characteristic of Pluto is the dark material that appears to be sprinkled across certain areas of its surface. The largest of these regions is known as Cthulhu Macula. In a curious trick of perception, its shape is strangely reminiscent of a whale, as seen in some imagery. This part of Pluto is far more heavily cratered than the heart-shaped region, which suggests its surface is considerably older. Mountain ranges are visible in the middle of Cthulhu Macula, and their peaks are capped with what scientists think are methane ices. It seems that methane condenses as a frost at higher elevations on Pluto. The dark coloration itself is thought to be from deposits of tholins, which are a type of tar formed when hydrocarbons are exposed to sunlight. Similar deposits have been observed on Iapetus, one of Saturn's moons, so the underlying process is not unique in the solar system. Scientists suspected this substance was tholins as soon as New Horizons began transmitting its first images, yet its distribution across Pluto's surface remained a puzzle. Why was it present in some areas but not others? Furthermore, how dynamic are the processes that govern the placement of these tholins? Has Pluto maintained this appearance for a long time, or is it a landscape in flux? It now appears these tholins might be directly connected to the cryovolcanism found on Pluto. Pluto is one of a select few worlds in our solar system where cryovolcanoes are actively reshaping the terrain. Water from the mantle, or perhaps from pockets of water trapped in the crust, erupts onto the surface, sculpting a varied landscape. What has become clear is that these eruptions do not consist of water alone. Tholins are distinctly mixed into the material. Data from Hubble had suggested Pluto was becoming redder over time, and New Horizons may have arrived during the reddest point in Pluto's year, uncovering the reason why. Here, in a region called Viking Terra, we can see a cryovolcano that has sprayed this water tholin slurry over its immediate vicinity. Right next to this area, a crater and a trough appear to have been filled by this slurry during a separate eruption. Near the trough, you can trace the path where this material flowed downhill and pooled. A similar process is evident in another region near Virgil Fosse, another trough where the slurry has traveled downward. The most fascinating detail about these tholins, however, is not found on Pluto itself, but on its companion dwarf planet, Charon. In an enhanced color image of Charon, one feature immediately draws the eye: the red cap covering its north pole. Incredibly, Pluto's gravity is so weak that when this slurry mixture erupts, some of it escapes the dwarf planet's pull entirely. This material then makes the 19,000-kilometer journey to Charon. The tholins are concentrated in this one location because Pluto and Charon are tidally locked. They perpetually show the same face to one another. In a more poetic sense, Pluto is always hiding its heart from Charon in this eternal dance. This arrangement means that more tholins accumulate on one specific spot on Charon, rather than being distributed evenly. Speaking of Charon, other interesting discoveries have been made about it as well. It is a world of water ice, unlike Pluto, whose surface is dominated by nitrogen ice. Consequently, it does not possess a substantial atmosphere like Pluto's, as the water ice remains frozen to the surface. On Pluto, the nitrogen ice sublimates according to the seasons, meaning its atmospheric density can change by many orders of magnitude throughout its year. With this constant sublimating and refreezing, Pluto's appearance may alter dramatically over its 2, 4, 8-year-long seasonal cycle. For many, the most impressive discovery New Horizons confirmed was that Pluto has an atmosphere. Beyond just its existence, the images returned are incredible. Because of Pluto's small size and low gravity, the atmosphere seems to extend far above the surface. Earth's atmosphere, while vastly more massive and dense, hugs our planet relatively tightly due to much stronger gravity. The atmospheric pressure on Pluto, by contrast, is exceptionally low, around 10 microbars. This is somewhere between 100,000 and 1 million times weaker than the surface pressure on Earth. It is theorized that this pressure could increase significantly to as much as 18 to 280 millibars, which would be 3 times the surface pressure of Mars and a quarter of Earth's. This might occur at different points during Pluto's long year. At certain times in its orbit, it travels closer to the Sun than Neptune does. This would raise the temperature, causing surface ices to sublimate into gas, a process for which there is evidence in the ice plains. The last time Pluto is thought to have had an atmosphere with a density similar to Mars was 900,000 years ago. At such pressures and temperatures, conditions might have been suitable for liquid nitrogen to exist on Pluto's surface. Some possible evidence for this may be a feature that looks like a frozen lake. In any case, Pluto's atmospheric density can vary by a factor of 4 within a single year due to these seasonal changes. This represents a massive contrast to other bodies in the solar system with atmospheres, which tend to remain fairly consistent. The atmosphere itself is composed of the same ices found condensed on the surface, primarily nitrogen, methane, and carbon dioxide. The other fascinating discovery New Horizons made about the atmosphere is that it contains up to 20 distinct haze layers. The existence of haze was not unexpected, but the sheer number of layers was a surprise. They are clearly visible in some of the images, appearing like stacked sheets of a thin fog. In one photograph, sunlight can even be seen streaming through one of these delicate layers. The view reveals deep shadows cast by the mountains, creating a sharp contrast with the sunlight that filters through Pluto's atmospheric haze. What is remarkable is that these layers of haze are not uniform across the planet. In one area, a distinct layer hangs high above the ground, while in another part of the same image, it appears to descend and touch the surface itself. These particular images, held back as a final, stunning perspective, offer a true appreciation for the depth and sheer scale of the mountain ranges. The world takes on the appearance of a miniature model, an effect created by its extreme topographical relief. These mountains can loom so high precisely because Pluto is a small world, and its gravity is too weak to pull their immense structures down. In June 2020, researchers published findings suggesting that beneath Pluto's frozen crust lies a vast ocean of liquid water, similar in nature to those on the icy moons of our solar system's gas giants. The long-held assumption was that Pluto must have formed as a cold body, given its immense distance from the Sunday. However, compelling evidence from the New Horizons mission points to a different origin story, one where Pluto began its existence with significant internal heat. This implies that the dwarf planet has likely possessed its subsurface ocean from the very beginning. If this hot start model is accurate, it presents the possibility that conditions for habitability on Pluto could be comparable to those on the closer icy moons. Furthermore, If Pluto serves as a standard for other dwarf planets in the Kuiper Belt, there could be a great many more potentially habitable worlds in our outer solar system. The evidence for this hot start is etched onto Pluto's surface. We see signs of expansion, not contraction. Visible fissures indicate the crust is pulling apart, rather than buckling and folding over on itself from cooling. Should this interpretation hold true, perhaps early, frequent bombardments from other planetesimals heated Pluto during the solar system's chaotic formation. It could mean that shortly after it coalesced, the dwarf planet had enough thermal energy to exist as a true ocean world. This concept fundamentally reshapes our perspective on how planetary systems can form. While the complete absence of craters is a feature mostly limited to Sputnik Planitia, the scarcity of impacts across both Pluto and Charon is astonishing. This might not only be a sign of relatively young surfaces, but could also suggest the Kuiper Belt is less populated with smaller objects than we once believed. The flyby itself concluded within a matter of days, sending New Horizons on a trajectory deep into the Kuiper Belt. The spacecraft had traveled so far from home by this point that when it observed our nearest stellar neighbor, Alpha Centauri, the star system appeared in a noticeably different position compared to our view from Earth. This phenomenon, known as parallax, is a direct consequence of the immense distance New Horizons had covered. It is a mind-bending thought that the probe has journeyed so far from us that its perspective has shifted the very stars. Conversely, it is also a humbling reminder of the vastness of space that after traveling all that way, this slight shift in our closest neighbor is the only perceptible change in the view. As New Horizons passed Pluto in 2015, it barely reduced its velocity at all. Its post-encounter path was designed to take it even farther into the Kuiper Belt. This region, so distant from Earth, is largely uncharted territory, a place no probe had ever explored. An intriguing question then arose. Did the mission team have another object in mind for a future visit? They did, and its name is Arakoth. Incredibly, they were not even aware of its existence when New Horizons first left Earth. What exactly is Arakoth? What is its appearance? And what makes it so unlike anything previously encountered? The year before the Pluto flyby, the New Horizons team was granted time with the Hubble Space Telescope to search for a potential target the probe could visit next. Hubble successfully identified 3 new objects, located reasonably close to the spacecraft's future path. After careful analysis of the data, a 35 kilometers long object, now known as Arakoth, was selected for the extended mission. This decision meant Arakoth would become the first celestial body to be visited by a spacecraft that was launched before the object itself had even been discovered. Following the Pluto encounter, New Horizons remained in excellent health, with propellant to spare and years of life left in its radioisotope thermoelectric generator. The mission team quickly transmitted commands, adjusting the probe's course to rendezvous with this promising new target. Being so small and distant, very little was known about the object. All Hubble could discern was its reddish color and the subtle dips and peaks in its brightness as it rotated. However, in a brilliant use of observational astronomy, scientists also witnessed Arakoth's occultation of a star. From this brief stellar eclipse, they were able to predict the object's general shape with remarkable accuracy, a prediction that would later be proven almost perfect. They knew at the very least it was an elongated body, suggesting it could be either a contact binary or simply a long, asteroid-like object. It would fall to New Horizons to confirm their calculations. 3 years after departing Pluto, in August of 2018, New Horizons officially began its approach phase from a distance of 172 million km. From this vantage point, Arakoth was barely a pinprick of light against the backdrop of distant stars. By December 2018, however, it shone brightly in the spacecraft's field of view. Traveling at 51,000 kilometers an hour, New Horizons was rapidly closing the distance, and the collection of science data was already underway. As the probe drew nearer and nearer, Arakoth's strange form began to resolve. Its appearance was unlike anything previously documented, revealing what looked to be a contact binary, a body with a lumpy surface that was relatively free of craters. It was a world entirely distinct from any asteroid or comet humanity had ever seen up close. On the 1st of January 2019, New Horizons made its closest approach, passing just 3,500 kilometers from Arakoth's surface. It was on this day that the majority of its scientific data was gathered. This historic flyby established Arakoth as the most distant object ever explored by a spacecraft, located 6.5 billion km from the Sun at the time, or roughly 45 times the distance between Earth and the Sunday. At this extreme range, the rate of data transmission between Earth and New Horizons was understandably slow, at only 1 kilobit per second. The fact that the technology existed to communicate with the probe at all is, in itself, an incredible feat. This slow transfer speed meant that it took approximately 2 years to send all of the collected data on Arakoth back to Earth. The highest priority information, primarily the images, was transmitted first, though it is memorable that the wait for the highest resolution pictures to arrive felt quite long at the time. When the first stories of the flyby were published, only low-resolution images were available, which suggests the general public never had the chance to see Arakoth in its complete splendor. Here, however, is the object in true color, captured in the highest resolution we currently possess. The first thing one notices about Arakoth is its pronounced reddish coloration. This quality sets it apart from the grayer and darker asteroids typically found closer to home, and it stems from a chemical similarity shared with Pluto. Its surface has a high concentration of organic compounds called tholins. These are molecules that have been altered by long-term exposure to solar and cosmic rays. The original organic compounds on the surface likely included substances such as methane and ammonia at some point in its history. Arakoth, however, no longer retains any of these materials, a loss attributed to its low mass. What spectral analysis of Arakoth does reveal is the presence of methanol, hydrogen cyanide, and water ice across its surface. This abundance of methanol is believed to be the primary reason for its red appearance, as irradiated methanol is the most probable source of the tholins. Yet, a mystery persists within Arakoth's spectral signature. An intriguing absorption band is present at 1.8 micrometers, but scientists have been unable to identify the compound responsible for it. This substance is unlike anything observed before. It is a shame a surface sample couldn't be collected to provide a definitive answer. The next observation that distinguishes Arakoth from asteroids in the inner solar system is the striking absence of small impact craters. This is thought to be a consequence of the fundamental nature of the Kuiper belt. This distant region could contain between 20 and 200 times the total mass of our asteroid belt. Yet a great deal of this mass is consolidated within large, Pluto-like bodies that are scattered throughout the zone. While the exact population of the Kuiper belt remains uncertain, it is undeniably more spread out than our asteroid belt, simply by virtue of being 20 times wider and having a vastly larger circumference. Being so far from the Sun also means that orbital speeds are considerably slower. As a result, when an impact does happen, it occurs at a very low velocity. For perspective, meteorites creating shooting stars in Earth's atmosphere can strike at speeds around 75 kilometers a second. In contrast, collisions within the Kuiper belt may happen at only 300 meters per second. The large depression seen here, which resembles a crater, may not have been formed by a collision at all. It could instead be a sinkhole created by the escape of volatile substances from just below the surface. This lack of violent collisions means that Arakoth, as we see it today, is a pristine time capsule from the early solar system, an object preserved for billions of years. A slow collision, however, is one of the leading theories for how this object was formed. When asteroids in the main belt strike each other at high speeds, they either create craters or shatter completely. A gentle impact, like those common in the Kuiper belt, can allow the two bodies to simply merge into one. It is also possible that the two lobes of Arakoth formed alongside each other inside a swirling cloud of ice fragments, which gradually coalesced into two separate, orbiting bodies. Eventually, these two objects would have drifted closer and closer until they finally joined. In either scenario, the merger would have occurred very slowly, given the noticeable lack of fractures or stress lines. The maximum speed of this union would have been no more than 2 meters a second. Furthermore, the two objects would have also needed to become tidally locked to one another before merging. The strong resemblance between Arakoth's two lobes lends weight to the theory that they formed in the same region. Before Arakoth received its formal name, it was known by its nickname, Ultima Thule. The individual lobes are now referred to as Ultima and Thule. One can also see several very bright regions on the surface. The bright spots inside the depression are likely the result of avalanches, where material collapsed inward after the sinkhole appeared. The other major bright patch is located around the connecting point between the two lobes. It is not known for certain why this area is brighter, but some theories propose that this region receives the least amount of sunlight. This would allow volatile materials like ammonia ice to accumulate. It could also be that because this region is near the object's center of gravity, loose material from the lobes rolls downward and collects in the middle. With a density of only 0.5 grams per cubic centimeter, Arakoth is not a densely packed object, but is probably highly porous. Volatile materials would have escaped from the interior over time, driven by an internal heat source. But these substances would then freeze on the surface, leaving only rocky remains inside. This heat source can still be detected to some degree. Models suggested that Arakoth should have a temperature of only 12 to 14 Kelvin. However, New Horizons found that it was actually 29 Kelvin. This is still extraordinarily cold, just not quite as cold as was expected. There is one last mysterious characteristic of Arakoth that is not immediately obvious from these images, and was only discovered after sifting through the New Horizons data. This characteristic is that Arakoth is, in fact, much flatter than it should be. This detail was not noticed at first because of the object's rotational orientation, which meant we never saw much of its profile illuminated from a side angle. We do not have a definitive explanation for why it is flat. It might have been caused by centrifugal forces when the individual lobes were forming, which would imply it was spinning much more rapidly in the past than it is today. Or perhaps it is due to the specific way Arakoth orbits and rotates, which results in one side of the object being constantly exposed to the sun for decades at a time. This would cause volatile substances to escape primarily from one side, before the other side is later exposed to the sun. Research is still underway to model the cause. As New Horizons moved away from Arakoth, it looked back and captured one last glimpse of its silhouette against the backdrop of stars. It is unknown if Arakoth will ever be visited again, so this may well be the last close-up view that we will ever have. What lies ahead for New Horizons? The spacecraft still has life in its battery and 11 kilograms of fuel on board. Consequently, the hunt is now underway to find any additional targets. Beyond that, it will follow the path of the Voyager probes, passing through the heliosphere of the solar system in the 2030 seconds. Even if no other Kuiper Belt object can be found close enough to its current trajectory for a third flyby, the New Horizons team is already submitting proposals for an extended mission that will have a completely different scientific focus. The plan for New Horizons is to transition the probe into a profoundly productive observatory, one that can conduct studies in planetary science, astrophysics, and heliospheric phenomena. These are observations that no other spacecraft can achieve, for the simple reason that New Horizons is alone in the Kuiper Belt and the Sun's outer heliosphere. Its unique vantage point allows for certain kinds of astrophysics that are otherwise impossible. The scope of these potential studies is broad, encompassing new astronomical surveys of Uranus, Neptune, and various dwarf planets. It also includes searches for elusive free-floating black holes and investigations into the local interstellar medium, alongside novel observations of the faint optical and ultraviolet glow from extragalactic space. Beyond its future potential, New Horizons has already delivered a trove of information about objects in the Kuiper Belt that would have remained unknown. No one could have predicted what Pluto would truly look like, or that its moon Charon would possess a prominent red cap, or that the object Arakoth would have such a flattened shape. Considering these are the only Kuiper Belt objects humanity has ever witnessed up close, it seems certain that many more surprises are waiting to be discovered out there. Pluto is undeniably a captivating object in our solar system, yet covering its complexities completely is a challenge. Discussions often lead to more questions, such as why Pluto is so difficult to see from Earth, especially when powerful instruments like the Hubble Space Telescope can resolve distant galaxies. Another common query is how the New Horizons photographs of Pluto were so brightly lit, given that it exists in the profound darkness so far from the Sunday. These kinds of questions are particularly insightful, as their answers provide a fascinating window into the fundamental workings of the universe. For anyone who has ever pondered the mysteries of Pluto, this is an opportunity to find some clarity. The answers to these questions are often intriguing, distinctive, and can even feel profound. The first question is a classic paradox. How can the Hubble Space Telescope capture distant galaxies with stunning clarity, yet fail to do the same for Pluto? Hubble has produced some of the most breathtaking cosmic images known to science, offering us clear glimpses of galaxies millions of light-years away. Despite this power, it has difficulty rendering sharp images of celestial bodies much nearer to home, like Pluto and other trans-Neptunian objects. On the surface, this seems to defy logic. How can an instrument see something so far away with such precision, while its most detailed view of Pluto remains a blur? The explanation is more straightforward than one might imagine and revolves around the angular diameter of the object being observed. This magnificent image shows the Andromeda Galaxy, located approximately 2 million light-years from us. One might assume that such a vast distance would make it appear quite small from our viewpoint. However, even at that range, a camera using a high exposure reveals that Andromeda is actually 6 times wider in our sky than the Sun or a full moon. This is a direct result of its immense physical size, stretching 220,000 light-years across. Given those dimensions, a distance of 2 million light-years is not enough to make it seem tiny. The combination of its size and distance gives it an apparent width of 3 degrees across the night sky. It is so expansive, in fact, that when Hubble turned its gaze toward it, the telescope could not capture the entire galaxy in a single frame. It simply was not able to zoom out far enough. Consequently, this famous image is a composite, a mosaic stitched together from hundreds of individual Hubble exposures. Even with this effort, the whole galaxy could not be fit into the final picture. This holds true for many other galaxies as well. While most are not as close or as large as Andromeda, they are still substantial enough for Hubble to image them and reveal interesting features. Here, for instance, is the Pinwheel Galaxy, which lies 21 million light-years away. It's notable how it spans the gap between several foreground stars within our own galaxy, which helps to convey its sheer apparent size. If you could perceive it clearly with the naked eye, it would appear only slightly smaller than the Moon. This should help put things into perspective. Even though an object is incredibly far away, its enormous physical scale can result in a large apparent size in our sky. As you might guess, this makes the task of imaging it much easier. As an aside, one can only imagine the celestial beauty we would witness if all the galaxies in our local group were bright enough to be visible without a telescope. But what does this mean for Pluto? To understand the difference, we need to clarify the measurements astronomers use to describe the size of an object in the sky. They employ degrees, arc minutes, and arc seconds, with 60 arc minutes in a degree and 60 arc seconds in an arc minute. Andromeda measured 3 degrees across, and the Moon is about 30 arc minutes wide. The Pinwheel Galaxy is approximately 28 arc minutes across. Pluto, even at its closest approach to Earth, measures a mere 11 arc seconds across. This makes it an incredibly tiny point of light in our night sky. It is something of a marvel that Hubble can resolve any surface details on it whatsoever. In contrast, closer and larger planets, which have much bigger apparent sizes, can be resolved more easily by Hubble. This is precisely why the New Horizons mission to Pluto in 2015 was so thrilling. Scientists genuinely did not know what to expect before the probe arrived, as no telescope was powerful enough to discern any real detail on Pluto from such a distance. Because of this, everything New Horizons transmitted back to Earth was a revelation. To bring the idea home with one last example from our own planet, consider this picture where you can see objects at various sizes and distances. Think of the flower in the image as Pluto. It is small and out of focus at this range. And yet, in the background, there are buildings much farther away than the flower that appear clear and distinct. Imagine these buildings are the galaxies that Hubble photographs. That should resolve the mystery of our first question. Now for the second. Why do Pluto and its large moon Charon orbit around a point in empty space? Not everyone may be aware that Pluto does this, but for those who have heard of it, the phenomenon can be puzzling. Does some invisible and tremendously dense object exist there? Perhaps a tiny, lurking black hole is responsible. As the New Horizons probe neared Pluto and Charon in 2015, it observed this orbital behavior up close and in great detail. In truth, however, an explanation involving a black hole is not necessary. Scientists were already expecting to see this long before New Horizons even arrived, despite never having detected anything at that specific point. The reason is that everything in space, not just Pluto, orbits around a barycenter. A barycenter is simply the center of mass between two objects. To help visualize this, if you place a large butternut squash on one end of a stick and a small kiwi on the other, you can see that the balancing point, or center of mass, is much closer to the butternut squash. An intriguing detail emerges when we compare the orbits of most planets and their moons to the unique dance of Pluto and Charon. For planets with substantially more mass than their satellites, the shared center of gravity, or barycenter, is located deep within the planet itself, causing the larger world to simply wobble as its moon exerts a gravitational tug. The situation with Pluto and Charon is markedly different because their masses are far more similar. This shifts their common orbital point to a location in the empty space between them, creating the remarkable appearance of two worlds swinging around an invisible pivot point. Curiously, the only other instance of this phenomenon among the major bodies of our solar system involves the Sun and Jupiter. This resolves one of Pluto's many enigmas, which leads to another common query. Many have wondered how the images from the New Horizons mission could be so bright, considering Pluto's extreme distance from the Sunday. A natural assumption is that Pluto would be shrouded in near total darkness. The reality, however, is that while it would appear dimmer to the unaided human eye than in these photographs, it is not nearly as dark as one might suspect. Fortunately, we can experience a direct comparison without leaving our own planet. Twice a day on Earth, during the twilight periods of dawn and dusk, the level of illumination in our sky precisely matches the brightness of high noon on Pluto. NASA has coined the term Pluto time for this experience, and a dedicated website can tell you when it will next happen in your specific location. As a practical example, even a standard mobile phone camera can still record video with ease during Pluto time. On average, Pluto is 40 times farther from the Sun than Earth is, receiving only 1/1000. 1/600th of the sunlight. To put this into numbers, direct sunlight on our world measures 100,000 lumens per square meter, whereas on Pluto, it would be approximately 60 lumens, which is equivalent to the lighting found in an indoor corridor or stairway. Even if this reduced light were an issue for a camera, darker subjects can be captured by employing longer exposure times. For instance, here on a dark night, a 15-second exposure allows my camera to gather and reveal a great deal of detail. If an image still came out too dark, its brightness could always be increased afterward using editing software. This combination of factors explains why Pluto appears so luminous in the New Horizons pictures. This brings us to one final question, which is perhaps the most prominent one the general public asks about Pluto. It is a query that is part genuine search for knowledge and part a cry against a perceived injustice, but its answer contains fascinating nuance. The question, of course, is why Pluto is no longer classified as a planet. Before explaining, it is useful to know that at one point, our solar system was considered to have as many as 100 planets. It is true that throughout history, the official count of planets has risen and fallen quite dramatically. This was not, it should be noted, because planets were suddenly materializing and then vanishing, but rather because of the evolving nature of their discovery and classification. Since antiquity, 5 planets were known beyond Earth, as they are visible to the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn. The ancient Greeks did add the Sun and the Moon to their planetary list, though that concept did not gain lasting acceptance. In the late 1700s, the discovery of Uranus was revolutionary, as no one had previously considered that more planets might exist beyond the 5 visible ones. Following this breakthrough, a growing number of planetary candidates were found, such as Ceres, Vesta, Pallas, and Juno, all located in what we now recognize as the asteroid belt between the orbits of Mars and Jupiter. Initially, however, these were not designated as asteroids. In scientific textbooks of the early 1800s, they were all listed as planets. Neptune was discovered in the mid-1800s, and within a few decades, we had accumulated a rather long list of planets. There simply was no clear distinction being made between the 8 major planets we know today and the large asteroids that were being identified. By the 1862, more than 100 asteroids had been located, and they were at last assigned their own distinct classification. Asteroids were described as objects that could be differentiated from stars by the fact that they moved across the sky. So, one might just as well question why Pallas is not a planet or demand justice for Juno. While many people feel Pluto has been wronged, it was merely another subject of this rigorous, ongoing refinement of categorization. In 1930, Pluto was discovered, and amid the excitement of finding such a large and distant body, it was classified as a planet. Within a few decades, however, it was found to deviate from the conventions of traditional planets. The planets we know travel in nearly circular orbits that are roughly aligned with the plane of the solar system. Pluto, in contrast, orbits at an angle to this plane. Furthermore, its orbit is so elliptical that during certain parts of its year, it is actually closer to the Sun than Neptune is. Yet, it was also unique, so for a time, no one objected to it being called a planet. Then, during the 1970s, Pluto was discovered to be significantly tinier than had been estimated. It turned out that its mass is only 1/6 that of our own moon. This created a bit of an awkward scientific inconsistency. Why should Pluto be called a planet when our moon, which was so much larger, was not? The challenges for Pluto's planetary status continued in the 1992, when telescopic technology had improved dramatically and other worlds began to be discovered in and around Pluto's orbit. Much like the earlier discovery of the asteroid belt, it soon became clear that another vast belt of objects existed beyond the orbit of Neptune, now known as the Kuiper belt. The discovery of these objects is still underway. The most famous ones include Eris, Sedna, Haumea, and Makemake, but a great many have been found, creating an extensive list. In 2006, the International Astronomical Union knew that action was required. It was time to establish a new definition for the word planet. They ultimately classified a planet as a celestial body that meets three conditions. A, it is in orbit around the Sun. E, it has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium, or a nearly round shape. And C, it has cleared the neighborhood around its orbit. While Pluto satisfies the first two requirements, it fails the third because it lies within the Kuiper belt and has not cleared its orbit. For this reason, it is not a planet. Some have made the argument that many of the major planets also have asteroids in their orbits. The difference, however, is one of scale. Having some asteroids around you is quite different from being situated within an entire belt of objects. Pluto is instead known as a dwarf planet, a category that is almost the same, except the object is not massive enough to have cleared its orbital path. We should not view this as a slight against Pluto. Rather, because of these new discoveries, we now have a whole new category of celestial objects to study and understand. This is Pluto, a strange and beautiful world so remote that the Sun appears as little more than a bright star in its firmament. The icy dwarf planet sits at the edge of the Kuiper belt, a disc-shaped region of dispersed bodies beyond the orbit of Neptune, and its surface looks like a fever dream of towering peaks, nitrogen ice glaciers, and winding canyons. It is extremely tiny, much smaller than our own moon, and yet far more colorful. The hues of its surface vary from white to red to burnt orange and charcoal black, creating a level of contrast in the solar system second only to Saturn's moon, Iapetus. Until recently, however, even powerful instruments like the Hubble Space Telescope could only resolve a few indistinct blobs of color on its surface. Pluto is so small and distant, remaining nearly 5 billion kilometers from Earth even at its closest approach, that our sense of what it looked like was vague at best. All of that changed in 2015, when NASA's New Horizons probe transmitted the first close-up images ever taken of Pluto, and they were simply astonishing. The full story revealed by the New Horizons mission is vast, and when it comes to Pluto, we still have many more questions than answers. What else can we learn about this world? What discoveries surprise scientists? And how are recent studies changing our understanding of the dwarf planet's past and present? The journey to these discoveries began in January 2006, when New Horizons launched from Cape Canaveral Air Force Station. Its primary mission was to photograph and gather information on Pluto and its moons, Charon, Styx, and Nix, as well as Kerberos and Hydra, which had not yet been discovered. On the 14th of July 2015, after 9 years in transit, New Horizons made its closest approach, capturing a breathtaking glimpse of Pluto's surface that exceeded our wildest imaginings. The probe revealed ice mountains, nitrogen glaciers, cryovolcanoes, and deep canyons. Given the immense distances involved, however, data transmission was limited to just 1 to 2 kilobytes per second. It ultimately took 15 months to downlink the complete dataset, and each time NASA released a new image, it caused a sensation. Looking at these images today, the sense of wonder has not dimmed in the slightest. There is so much information to unpack. It feels a bit like working on a complex puzzle, and like any good puzzle, the fuller picture only reveals itself after you have taken the time to piece it all together. A fascinating place to begin is a unique feature informally called the brass knuckles. Located near Pluto's equator, this formation is comprised of 6 lowland regions known as maculae, each with an average width of 480 kilometers, roughly the size of Iceland. A closer look reveals that they are interlaced with a network of canyons. From west to east, their official names are Kroon, Alla, Balrog, Vukubkeme, Hunkeme, and Mengpo, Each of these names is drawn from a different netherworld spirit from world mythology. For fans of Time's The Lord of the Rings asterisk, it may be exciting to know that Balrog Macula is indeed a reference to the wizard-battling demon of Middle-earth. It is thought that the brass knuckles get their dark color from a tar-like substance made of tholins, which are hydrocarbons formed from the interaction of methane and nitrogen with cosmic rays. Tholins are abundant across Pluto, such as in the neighboring, whale-shaped region known as Cthulhu Macula. The reason the brass knuckles appear as separate patches is that each macula is divided by towering uplands covered in ice. These uplands stand several kilometers tall and are likely made of frozen nitrogen, methane, and carbon monoxide layered on top of a bedrock of water ice. On Pluto, water ice is strong enough to form mountains, a consequence of the world's low gravity. Nitrogen ice, by contrast, is much softer, which explains why it tends to flood the lowlands. One can only imagine what these colossal ice mountains must look like from the perspective of the canyons below. Nitrogen is the most common material on Pluto's surface, making up 98% of it. In fact, nitrogen ice also accounts for a large part of Pluto's most iconic feature, its heart-shaped region known as Tomball Regio, named after its discoverer, Clyde Tombaugh. The western lobe of this heart is a smooth basin filled with nitrogen ice called Sputnik Planitia, while the eastern lobe is much rougher. In the detailed imagery, you can see the relief with remarkable clarity. Scanning from west to east, one can almost feel the textural difference. The eastern side appears pitted, almost like the skin of an orange. Scientists believe Pluto's winds carry nitrogen from Sputnik Planitia up into the atmosphere and then deposit it back onto these eastern uplands, which is why their albedo is so high. Albedo is the measurement of how much light a surface reflects, and these uplands have a bright, icy sheen due to all the nitrogen ice deposited there. It is thought that some of that nitrogen, in turn, slides back into the lowlands through glacial flow, suggesting the western and eastern halves of the heart share a transactional relationship. Over on the western side of Sputnik Planitia is a towering mountain range called Alcyone Montes. Here, the winds blow tiny particles of methane ice toward the mountains, depositing them back onto the surface, much like grains of sand forming dunes. This process is remarkable in itself, since Pluto's atmosphere is incredibly thin. Because of the classification change that redefined Pluto, there was a silver lining for the object once known as the largest asteroid, Ceres. It was promoted to the status of a dwarf planet. While some questions about Pluto have been answered, many more have arisen. As we learn about its icy beauty and its profound mysteries, our minds are sent turning in even more directions. It is like a mythical hydra, a beast that can never be slain by simply removing its heads. But this is part of the beauty of the universe. We can learn so much, and yet there is always so much more to discover. It is the journey, after all, that is often the most satisfying. The capacity of Pluto's winds to transport material in this way was not anticipated. The most probable explanation involves methane particles being lifted by sublimating nitrogen ice, a process where a substance transitions directly from a solid to a gaseous state. It is thought that this outgassing of nitrogen dislodges tiny, grain-like particles of methane ice, which are then carried up into the atmosphere before settling nearer to the mountains. These methane deposits have formed an expansive 2,000-kilometer field of transverse dunes, bearing some resemblance to those found in China's Taklamakan Desert or California's Death Valley. Yet, a striking difference from these terrestrial deserts is that Pluto's dunes exist at frigid temperatures of negative 230 degrees C. The minuscule methane grains that constitute the dunes are significantly lighter than sand, and within Pluto's low gravity, they would probably feel like fine dust flowing through your fingertips. Given the extreme cold, however, attempting such a thing would not be advisable. The dunes are not the only feature of interest in this region of Sputnik Planitia. Along the western edge of the mountains lies a deep trench, which appears as a dark blue ribbon on this color-enhanced elevation map. According to measurements, the peaks immediately next to the trench range from 200 meters to 1 kilometer in height. In contrast, the more distant peaks are much taller, reaching up to 3 kilometers, nearly the stature of the Rocky Mountains. This indicates that the mountains increase in elevation the farther one moves from the trench. The significance of this observation may relate to processes occurring deep beneath Pluto's surface. One of the most compelling recent revelations about Pluto is the possibility that it once had, and may still possess, a vast subsurface ocean. This would be a characteristic it shares with several moons in our own solar system, including Ganymede, Europa, and Enceladus. The very idea that Pluto could harbor liquid water is remarkable, considering its great distance from the Sun. It would need to generate substantial internal heat through nuclear decay within its core. Yet, Pluto is smaller than our Moon, and the diminutive size of its core would not be expected to produce a large amount of heat. Consequently, the evidence for a subsurface ocean was a surprise to many researchers. While this is a fascinating concept, its connection to the mountains requires clarification. A 2019 study presented at the Lunar and Planetary Science Conference puts forth an argument that the Al-Idrisi Montes have likely shifted eastward through a process of solid-state convection. This movement could have simultaneously created the deep trench on the mountain's western flank and produced the uplift observed in the rising peak elevations from west to east. If this theory holds true, such dynamic surface processes on Pluto would seem to reinforce the idea of a liquid water layer existing beneath its frozen crust. Other evidence also points in this direction, particularly in the form of cryovolcanoes. Right Mons is one such potential cryovolcano previously examined, and here it is in the highest resolution color view assembled by the New Horizons team. What we are looking at is a composite of images captured by the probe's LORRI camera and its Ralph multispectral visible imaging camera. Right Mons is a colossal structure composed mainly of water ice, standing 4 kilometers tall with a vast depression at its center. Its lack of impact craters in the surrounding area suggests it may have been active in the relatively recent past. Scientists have also identified another potential cryovolcano to its southwest named Picard Mons. This feature is even more massive, rising to a height of 7 kilometers. Unfortunately, it was already slipping into darkness when New Horizons was in a position to image it. As a result, the visuals are not as sharp as those of Right Mons, but it can be seen here in a colorized topographic map. It, too, features an enormous depression at its summit. The central depressions on both structures are reminiscent of calderas seen on Earth, although they are much larger in proportion to the size of the volcanoes themselves. A closer look reveals what appear to be concentric rings around these depressions, possibly indicating a sequence of eruptions followed by the retreat of magma and the subsequent collapse of the vents. It is important to note that their status as cryovolcanoes has not been definitively confirmed, but the accumulation of suggestive evidence is compelling. These features represent another group of incredible discoveries made by New Horizons on Pluto. The surprising revelations about its potential subsurface ocean ensure that much more research on the dwarf planet will follow. This leaves us to wonder what further discoveries await. Could life one day be found in Pluto's hidden ocean? Might a future probe be sent to another dwarf planet in the Kuiper Belt, such as Eris? Such a mission has been proposed, but the spaceflight alone would take more than 20 years. This long timescale only enhances our appreciation for the wonderful images New Horizons has already provided.